In this video, we'll like to improvise the physics of the particles with respect to the speed, motion, and the accuracy. Like we have already discussed in the previous clip regarding the motion of the particles, that we have already synchronized their velocity with respect to the fluids, which in itself as a field, okay? But we also going to observe that if I'm going to show you up with the play blast first of all, which is this one, and let me just gonna put that to the loop. So here the case is that the particle motion is really a slow, and that's the reason I am not going to consider that, and this is why this is happening because of the simulation rate scale. First of all, let me just gonna put that into the pause. We just tweaked down the attributes of the fluid container from 2.5 to the 1.5. That is the simulation rate scale, which was overall affecting the behavior of the fluids, okay? But now, as we have already linked up the velocity of the particles with respect to the velocity vectors of the fluids, so now the fluids is slow, the particles obviously have to be slow. So I would like to take down that thing back. Let me just gonna close that thing, and inside the fluid container I would like to go with the simulation rate scale that I just gave 1.5. Instead 1.5, I would like to bring that thing back to the 2.5. okay? So with the 2.5 simulation rate scale, we're going to observe some few more changes. And now in this case you can see there is a lot of change inside the particles in terms of the speed and the physics and the accuracy as well. But there is another issue. Well, the issue is clearly visible over here and over the top sections of the fluid container. Once you notice that the particles are getting away from the threshold of the fluids, or you could say in simple terms, like we have given the conserved 0 or almost 0.2 or 0.1 to the particles. Once they start leaving the threshold of the fluids, which means that fluid is also being an energy, which we have already given some dissipations both in the density as well as in the temperature zones. So when this energy is getting dissipated, or you could say start getting fade up, the particles will also going to lose their velocities, and you can notice that the particle is really fast in the middle of the fluids, but once it is leaving the fluids, it is again getting back to the zero, not to the zero, but it's getting stuck. So what will going to happen at the frame 100, or you could say at frame 150, most of the particles will start getting accumulated over here, because they'll start leaving the threshold of the fluids, or you could say that the fluid velocity vectors become little bit weak to affect the overall particles. So the way out is that we're going to provide some additional fields to the particles so that we can improvise the stuff. So I'm going to show you another play blast, which is an improved version of the particles, but once let me just given with some changes inside the particles. If we're going to play the timeline, now you're going to notice that the particle will really going to pick up the speed, because I've already changed the attributes of the simulation rate scale from 2.5 to, from 1.5 to the 2.5. okay? Now it's time to remove the problem in which the particles were actually getting stuck over to the top and the right section of the fluids, okay? And there is another thing that we also need to take care, which is the lifespan of the particles. Obviously these are the ambers, and they do need to die, or they do need to fade inside the atmosphere. They can't just live for forever. Now the property of the particles, you can say under the amber shape, is showing that the lifespan mode is live forever, which is not possible. So just to create some more accuracy inside the behavior of the ambers, we would like to tweak the value of the live forever to the random range, and here the lifespan will go with the 3.5 to maybe 1.25. Now the lifespan random will going to indicate the plus 1.25 or negative 1.25. so that means the lifespan 3.5 will going to indicate that if we're going to go inside the preferences and under the settings, we do have the film 24 fps, and okay, let's just do one thing. First of all, I'd like to put that into the 25 fps, so that will be good, and again get back to the 0 that would be good. So now what this attribute means, the lifespan 3.5 means that the particle could live for the age of let us say 100, because this is indicating 3.5 seconds. So in 1 second we are including the 25 frames. So if you're going to multiply the 25 to the 3.5, you may could end up with, let's say, 90 or maybe 85. Okay, so in that case the particles will gonna die at the frame 85, but they may could extend their life with respect to the addition of 1.25 seconds, or maybe from 3.5 they will get reduced to, I guess, 2.25. Okay, so this random will gonna play the per particle role. In some particle case their life will be 2.25, in some case the life will going to be 4.75. okay, so that, I think so, that should be clear. And if you don't want the life to be too high, we could reduce from 1.25 to the 1 only. Okay, and from lifespan, let's say 3.5 will going to be okay. Now let's just do one thing. The shapes of the particles were also not like that much convincing, because the high speedy particles also do carry some stretchiness, or you can say they do get stretch, or they may gonna come with the look and feel of a streaky kind of a stuff. So instead of the point, I would like to go with the streak type particles, and this is just only for the render preview. These particles will not going to be get rendered until unless we're going to change them from the streak being an hardware render particles to the tube, which is a software render particles. Okay, so that workflow we're going to discuss a little later. So at least for now we're going to stick to the streak. Okay, and let me just gonna play the timeline, and here you're going to notice that there is a significant change inside the motion of the particles as well as the shape of the particles. Now those particles which are a little closer to the tree, they have been getting a little stretch because their velocities are very high near on the center of the tree. So let's just do one more thing. Let's just switch on the color accumulations just for our, you can say, render purpose, or you could say for the viewport visualization purpose. So that will gonna increase the color values once they'll start getting accumulated upon each other. And I'm also gonna change the line width from 1 to the 2, and also the tail size from 1 to, let's say, 0.5, and the tail fade to be 0.5 again. We make it work with 0.65 as well. Okay, and the line width, I guess 1 seems to be pretty okay, maybe 1.25, but we don't have, I think so, that accurate value. Okay, no problem, we're gonna stick with the 1 again. And now if you're gonna notice that the particles, they do have some more changes, but I also do need to take care of the opacity of the particles, because you can notice that the shading of the particles, which is over here, is exactly the same for those particles who are here, which clearly means that there's some problem. What I mean to say is that the particles should also get started fading away, or they may also get start diminishing with respect to the age or to the time, just like the way fluids are being getting diminished. So what I'm going to do here is that I need to select the particles, and would like to go under the per particle array attributes, which decides that the per particle age of the particles, which means every particle will be get calculated separately. So for that I need to go to the opacity, I need to click the add per particle attributes, add attributes, and with that we're gonna get the opacity pp, that stands for the per particles. So what we can do, let's say right click over here and create a ramp. Let's say we're gonna put that thing to the input u to the none, v to the particle age, and that's a new ramp, and click OK. And once I'm gonna do the right click and go inside the edit ramp, you're gonna see a gradient, which means this is the starting position of the particles, and the particles are completely bright in the beginning, and once they are gonna die, I mean once they complete the 3.5 to the 3 values in their random lifespan stage, they're gonna get start fading up. We could also improve the interpolation from linear to the smooth. That will also gonna bring some more changes. Okay, so with this, if we're gonna play the timeline, you're gonna notice that although it's a little difficult to observe, we'll need to show you the play blast, that the particles, those who are near the tree, or you can say at the center of the tree, they are pretty much brighter, and the particles that are, you can say, going towards this sections, they'll started losing their opacities. So which is also very realistic in terms of the shading and the accuracy, you can say the overall physics of the particles. Okay, now for the last thing, we also do need to provide some fields to the particles so that they shouldn't be get affected or get stuck to the containers of the fluids. So for that we need to go to the outliner again and click the embers. My first field will going to be the turbulence, so it will gonna bring some more randomness inside the nature of the particles once they leave the threshold of the fluids. And I'm gonna start with the magnitude of, let's say, 50, and attenuations and all, set that thing to the 0. We don't want that, it should be attenuated. And of course we like to play with the frequency, let's say I guess 0.1, 0.25, or maybe 0.85 should be the idle values. That leave it to your artistic decisions. Okay, and then I can select the embers again and go to the field solver and provide the air. So the air, we're also going to lift the particle a little bit upwards, but here in this case we don't want the particles to move only towards the y-axis, we also want the particles to move towards the z-axis also. So for that I need to take the direction y positive and the direction z to be negative y. So in this case the fluid should move towards the 45-degree angles, not to the straight, not completely towards the right side. Okay, so once we are done with these, I would like to show you the last play blast, and here you're going to notice that the particles are now adhering to the opacity. Let me just put that in the loop again. Now the particles are, you can say, following the opacity, the graph we just given, and it is affecting per particles, and there is no problem in terms, you can say, there is no accumulation of the particles. And once the particle is leaving the threshold of the fluid container, it's still being getting drifted, or you may could say getting advected with respect to the fields that we just provided, that is the turbulence and the air. The role of the air would be simple, to lift the particles in upward or right side directions, and the motion, or you can say the role of the turbulence, is simply going to be to add some more randomness inside the velocities of the particles. Alright, so I guess this must be clearly understood to all of you. And now it's time to create the shading inside the particles. So now it's time to move to the next module.